Good day, my students. You are welcome to today's class. We'll be looking into the applications of Pythagorean theory. That is, please, to wrap up this topic. Previously, we have looked into how the formula of Pythagorean rule can be applied or can be used in solving problems that involve right angle triangle, looking at the size and all that. And the second lesson, we looked at the Pythagorean triple, how a set of three whole number can be, determine whether they can satisfy the Pythagorean rule or they form a Pythagorean triple. But today we are focusing on the application of Pythagorean theorem. Now, Pythagorean rule or theorem can be applied in solving word problems in trigonometry, especially in areas like angle of elevation and depression, bearing and distances, and in mensuration. For instance, I want you to look at this. Remember, we are looking at word problems. Word problem is not as if the triangle will be drawn for you to find the side. This time around, you have to draw the triangle, determine the side that is given and the side that you are looking for, and then apply the right formula in order to calculate it. The question says, a ladder 10 centimeter long reaches 8 centimeter up a vertical wall. How far is the foot of the ladder from the wall? I take the question again. A ladder 10 centimeter long reaches 8 centimeter up a vertical wall. How far is the foot of the ladder from the wall? How far is the foot of the ladder from the wall? Now, the first thing you have to do is to make a sketch. If you like, you can sketch it in real life. Just sketch the wall, sketch the ladder. Now, in this my diagram, I just draw the diagram in form of a triangle. The 10 centimeter is representing the ladder that lays on the wall, 8 centimeter. Now, the distance between the foot of that ladder and that of the wall is x. I label it x because it's not given, so that is what I'm looking for. Okay? Now, if I may ask, what formula are we going to apply on this? The answer is Pythagoras rule. That is Pythagoras rule. Okay? So the longest side in this my triangle is 10. So 10 represents the hypotenuse, while x is and the 8 centimeter side is the adjacent sides. Now, solution. Applying the Pythagoras rule, you have c squared equals a squared plus b squared. But because we are looking for x is one of the adjacent sides, so it's going to change to b squared equals c squared minus a squared. Now, instead of b, now I now represent my b as x. So x squared will now give us, c squared will give us 10, because 10 is the hypotenuse. So 10 squared minus 8 squared. In the next step, 8x squared equals 100 minus 64. I take that again. X squared equals 100 minus 64. Now, if you subtract 64 from 100, you will have 36. So, in the next step, we have x squared equals 36. When you square root both sides, you are going to have that x equals square root of 36. Therefore, x equals 6 centimeter. So the distance between the foot of the ladder and that of the wall is 6 centimeters. I believe the challenge now should only be to sketch the diagram. Solving shouldn't be a problem because we have done a great work on using the formula. And let's look at the second example that I have here. Second question that I have here is a kind of bearing, but in this case there is no angle. It's just directions that we use here. It says a boy left his school. A boy left his school and walked, I beg your pardon, that's walked, and walked 3 kilometers eastwards to his house, and then 4 kilometers southwards to his father's office. Calculate the distance from the school to his father's office. Calculate the distance from the school to his father's office. I want to take the question again. At least you should be able to know the 4 cardinal points, because that is what we use for this question right now. It says eastwards. It's moving eastwards from the particular point where the school is located. He moved eastwards. And when you say eastward, it's directly eastward, not southeast or northeast, eastwards. So 3 kilometers eastwards to his house. And then whenever you are dealing with problem in bearing and you see and then, it means a change of course. So from that their house, he now walked 4 kilometers southward, that is due south, to his father's office. Now the question: calculate the distance from the school to his father's office. 3 points, 3 stationary points there. 1, the school. 2, the house. And 3, father's office. That is how to get it. First station there is the school. The second station there is the house. And the third station is the father's office. So these 3 points, 3 stations, forms the apex of the triangle, forms the edges of the triangle. So I will represent the school with S, represent the house with H, and represent the father's office with O. And let's look at the triangle. Can you see it? The S stands for the school. He walked 3 kilometers from school to the house. You can see it. Eastwards. Now on reaching home, he now walked 4 kilometers to his father's office. You can see O there. O stands for office. Now the question is the distance. We have to calculate the distance from school to his father's office. So there I represented it with D. Okay, so can we now do the work? I believe somebody is already solving it. Very simple. Somebody is already getting the answer without even solving. That's very good. All right, but let's look at the solution. Applying the Pythagorean rule, c squared equals a squared plus b squared. But because we are looking for d, we change the c to be d squared equals our a there. We represented it with 3, or a is given as 3. So 3 squared plus B side, which is 4 squared. Now D squared will give us 9 plus 16. And the sum of 9 and 16 is 25. So D squared equals 25. Square root both sides. When we square root both sides, we have D equals square root of 25. And square root of 25 will give us 5 kilometers. 5 kilometers. Hence, the distance D from the school to his father's office is 5 kilometers. Very, very simple. I believe somebody is appreciating this class. Okay? Somebody is appreciating this class. Yeah. So this is the much that I can go in this lesson. This is just to wrap up this topic. You can check the test, check your workbook, take more of this. You can even try some questions from the straight past questions. Try out some questions and let's discuss it later. Okay? Now this, I have 2 questions here to guide you. In case you couldn't lay your hand in any of these type of questions, then you can try these 2. The first question here says, a ship left a harbor. The name of the harbor is X, and sailed westward to another harbor, Y, which is 6 kilometers from X. He then sailed southwards to another harbor, Z, which is 8 kilometers from Y. The question now, calculate the distance, X, Z. Second question says, a pole 17 meters long leans against a vertical wall measuring 15 meters in length. Calculate the distance from the foot of the pole to the wall. Calculate the distance from the foot of the pole to the wall. Thank you and have a nice day. I remain Mr. Noah Lawrence, your mathematics teacher. Bye.